Hello everyone and welcome to another trig video. Today we're going to be talking about law of sines, oblique triangles, ambiguous case of law of sines at 7.1 and 7.2. Maybe, depending on how long the video goes, we might touch on 7.3. There's actually one other piece here, application 7.1 through 7.3. I'll finish up chapter 7, and then we've got chapter 8, which is 4 sections long. You guys are going to be done on May the 4th. That's when your final exam should be. I'm waiting on that right now. But that means that we have this week and next week to get through both chapters, get to this unit, take Unit 5 tests, and then you will have the final exam, and then you'll be done with trig. So let's not waste any time. Let's go ahead and get straight into it. So 7.1, 7.2, we're talking about law of sines. So to solve right triangles, we use Pythagorean theorem along with sine, cosine, tangent. To solve oblique, which is not right triangles, we use law of sines. Side measure over sine of angle. And equals, each one of these are equivalent. So side A over sine of angle A, and so on and so forth. Using the law of sines, you may find it helpful to draw diagrams. I always draw a diagram. I'm going to give you that little bit of advice. Draw a diagram. When you determine your solution, you must always check for geometric accuracy, which means that longest side should be across from largest angle, smallest across from smallest. Okay, so let's go ahead and get right in. So we've got this triangle, and we are given. Okay, there's my triangle. Here's angle A, angle B, angle C. We know that angle A is 32 degrees. We know that angle B is 81.8 degrees. And we know that side A is 42.9. And that's inches. So to solve a triangle, you've got to find all sides, all angles. Now, to find this angle, I'll go ahead and say let's find angle C, because we know that all angles of a triangle have to add up to be 180 degrees. So I'm going to do that the measure of angle C is 180 subtract 81.8 plus 32. And that's going to be 180 subtract 113.8. So the measure of angle C is going to be 66.2 degrees. So this is 66.2 degrees. So all angles are found. Now we do sides. And then for this, we're going to use law of sines. I'm going to do it over here. So I'm going to go with finding side B first. So that means that I've got to do A over sine of A, so 42.9 over sine of 32 degrees is equal to, I don't know what side B is, but I know that I have to do sine of 81.8 degrees. We cross multiply, so 42.9 sine of 81.8 is equal to B times sine of 32. I want to solve for B, so divide by sine of 32. So make sure your calculator is in degree mode. Since we're talking about degrees, make sure it's in degree mode. And I type this into my calculator, I get that side B is 80.1, it's 128, so I'm going to go 80.13. Now I repeat this process again for C. So I'm going to use 42.9 again over sine of 32, and this time I want side C over sine of angle C, which is 66.2 degrees. cross multiply, which really in this case all we really have to do is just multiply by sine 66.2. It's going to move to the top, so that's what I'm going to do. When we type this into our calculator, 42.9 sine of 66.2 divided by sine of 32, and we get 74.07 inches. And don't forget my units, inches. And that's all there is for number 1. If you notice, look, I've drawn a diagram, found an angle, and done law of sines twice in order to solve the triangle. So you need to make sure that you give yourself plenty of space to work out these problems. And let's move on to the next one. Alright, this time, same picture, A, B, C. I'm going to go ahead and convert these. So this is 20.83, and this is 103.17 degrees. Remember, we divide this by 60, turn it to a decimal, keep 2 decimal places. So B, we got 20.83, and C, we have 103.17, and BC, which is B to C here, is 132 centimeters. Yet again, we can find very easily angle A right there. So measure of angle A is 180. Subtract 103.17 plus 20.83. So it's really 180. Excuse me. Subtract. This looks like 124. So measure of angle A is 56 degrees. And now we can do our law of sines. Doesn't matter which one you start for this. I'm going to start with B. So I need 132, which is A, over sine of 56 is equal to B over sine 20.83. Yet again, we don't have to do the full cross multiply since we're trying to solve for this numerator. I just have to multiply by the denominator, which moves it to the top of the other fraction. So I got 132 sine of 20.83 divided by sine 56. And we type that into our calculator, 132 sine 20.83 divided by sine of 56. I get 56.62. I've got over there 62 centimeters. And finding C, 132 sine of 56. C over sine of 103.17. Multiply 132 sine 103.17 over sine 56 is a little c. So little c is going to be equal to 155.03. Now I didn't do this with the last problem and I forgot. We need to check for geometric accuracy. So largest angle is angle C. So that means that the largest side should be side C, which is the 155.03. And B, let's put him on here, 56.62. 8.62. So largest should be across from largest, and that works. Smallest should be across from smallest, and that works. And middle should be across from middle, and that works. So this is solved. Alright, example 3. Now we're going to be talking about some of the ambiguous cases. And what that means is that sometimes there are two different triangles that can present themselves when we do these problems. So I'm going to draw this triangle here just to fill in what we have. It's going to be A, it's going to be B, it's going to be C. And I've converted this to 127.67, which I'm writing in here. And across from C, I've got 14.23. And across from B, I've got 8.41. So now what I'm going to do, I do not have any information about A. I don't have enough information to try to solve for A, but I do have enough information to solve for B. So I'm going to try to do that now. So I need B, which I don't have. Actually, let's start with what we do know. We know that C is 14.23 over sine of 127.67. We don't know B. Well, we do know B, sorry. We know it's 8.41. We don't know what angle B is. That's sine of big B. Now this time I actually am going to go through the whole cross multiply, so I'm looking for a denominator. So 14.23 sine of big B is equal to 8.41 sine of 127.67. I'm going to divide by 14.23. And what I'm going to do is I'm going to take the sine inverse of both sides, which means that I'm going to be solving for the measure of angle B, which is going to be the sine inverse of all of this, 8.41 sine of 127.67 over 14.23, because I really want to know what this angle is. So I'm going to type that in my calculator now. Sine -1 of 8.41 sine 127.67 divided by 14.23. And I get that the measure of angle B is 27.89 degrees. Well, the ambiguous case of sines means that there could be, and this only happens when we have what we call SSA, side-side angle. Okay, see this with me again. From B to A, that's a side. A to C is a side. And then the angle that's in between and across, so angle C here. When we have these three items, that's what we're starting with, which is side-side angle. That's when the ambiguous case can appear. That doesn't mean it always does. What this means is that we look, there could be two cases. Case 1, which is what we just found, is that we could have that the measure of angle B is 27.89. But we know from trigonometry, all that we've studied, is that if I have this triangle right here, and let's say this is 30 degrees, that means this is 1, this is square root of 3, and this is 2. If I did sine of 30, you would tell me that's 1/2. But from this trigonometry that we've been studying all year, you also know this over here. If I wanted to know sine of this angle, you would also say that that is 1/2. Well, this angle here is a 30-degree angle, but if we're talking about from here, that's really a sine of 150 degrees. So you can easily see, based on what we've done all year, that there are two angles that can give me the same answer. And that's why we have what we call the ambiguous case, is that there could be another angle that gives me the same answers. Well, how do I find it? Well, what's the relationship between these two angles? The relationship here is that they both add up to be 180 degrees. Or if I did 180 subtract 150, I get 30. Or the other way around, 180 subtract 30, I get 150. They add up to be 180 degrees. They're supplementary angles. Which means that case 2 would be that the measure of angle B would be 180 degrees, subtract 27.89. That gives me that the measure of angle B in case 2 would have to be 152.11. Now, as I said a minute ago, this ambiguous case can appear. Does that mean it always does? No, because right now we do have to follow these three basic informations. Okay, C has to be 127.67 degrees. That is given. It has to be this way. 14.23, 8.41, these all have to stay as they are. Any new information would follow the ambiguous. Based on that, can case 2 even exist? The answer is no. 152.11 and 127.67, if those were added together, would be more than 180 degrees, which means this triangle does not exist. So case 1 is the only one we can use. So that means that angle B, and I know this is a lot to take in, which is why we're going to have several problems. Once you start seeing the pattern of the ambiguous case, you'll start understanding more and more. Angle B is 27.89 degrees. What is angle A? Well, it's 180. Subtract out the 27.89 and subtract out the 127.67. So this measure of angle A is 24.44. Okay, got all three angles, got two of the sides. Let's get the last one. We need A. So that one, I always start with what we know. So 14.23 over sine of 127.67 is this little side A here over sine of that new angle 24.44. Do our multiplying trick. 14.23 sine of 24.44 divided by sine of 127.67, and that would give me little a. So little a, type it in my calculator now, is 7.44, and that's centimeters. So just to recap what we've done, A is 7.44, we know B is 8.41, C is 14.23. We know that angle A, 24.44, angle B, 27.89, case 2 does not exist. And then we have our given angle C, checking geometric accuracy, largest angle, across from it is the largest side, smallest angle, and your smallest side, and they're across from each other. So, everything worked out just like it should. Okay, example 4, drawing my triangle. Now, as I said at the beginning of the video, I highly recommend you draw triangles. Even if there's an ambiguous case, that means you'd have 2 triangles to draw. Okay, so make sure that you look at that. Okay, So go ahead and convert this as 55.67 degrees. So right here, 55.67. Across from it, 8.94. And across from B, 25.1 centimeters. Now, looking at this, we have a side-side angle, which means that we have to look for an ambiguous case, which means the next angle that we solve for, we have to try to figure out, is it that angle? Is there another angle? Remember, they have to add it to be 180 degrees. So let's do that now. Let's go ahead and find angle B. Setting up what we know that 8.94, that's side C, over the sine of angle C, 55.67, has to equal 25.1 over the sine of angle B. Cross multiply. Divide. And take the sine inverse. Alright, so we'll type that in right now. Got 25.1 sine of 55.67 divided by 8.94. And when I type that in my calculator, this is what we get. Now, just to show you why, I'm just going to compute what's inside here. So 25.1 sine of 55.67 divided by 8.94. That gives me 2.32, roughly. Well, remember that the sine curve, unless it's been stretched, only goes up to 1 or down to -1. It does not reach 2.32. That would be a cosecant. So this is outside of its domain. Therefore, this particular triangle does not exist. You cannot make a triangle of this given information. And we scroll down to number 5. Only two more, as you can see, 5 and 6. Alright, with number 5, I'm going to go and draw my triangle. You get really good at drawing triangles when you're practicing law of sines and cosines. This is 55.32 degrees. So across from that, 22.8, and B, 24.9. Yet again, side angle. Okay, hopefully you're seeing that. I'm going to draw little S's. Side, and then there's angle A. So side angle. So that means we have to check for ambiguous. First thing, given the information we have, we know nothing about C. We have to go for B. Okay, so go with what I know. 22.8 sine 55.32 equals 24.9 sine of angle B. Cross multiply. So divide by 22.8, and then we, of course, we do our sine inverse. Type that in. And I get 63.91. That's case 1. Now we need to check about case 2, which means I need to do 180, subtract the 63.91. Which gives me 116.09. Now, can this fit into our situation? Well, 116.09 plus 55.32 gives me 171.41. So that means that this could be a proper case. So what I'm going to do is I'm going to move this thing out of the way first. Put it up here. This is going to be case 1's triangle. And this down here is going to be case 2's triangle. Now, none of the given information changes. Okay, none of that given information changes in these cases. The only thing that's going to change now is that angle B for case 1 is going to be 63.91. And in case 2, it's going to be 116.09. Okay. Now, in both cases, we need to find out angle C. So in case 1, I'm going to do 180, subtract out the 55.32, and subtract out the 63.91. That leaves me with angle C being 60.77. In case 2, same thing, just using the different numbers. Subtract out 55.32, subtract out 116.09. That leaves me with this angle being 8.59. Okay, last thing we have to do is find the last side. I want to do trying to do a separation here, and I did not do a very good job. Put my 60.77 back. Okay, so I'm going to draw a separation. And I'm going to work out case 1 up here, case 2 down here. So case 1, 22.8 over sine 55.32 has to equal side C that we don't know over sine 60.77. So C has to be 22.8 sine 60.77 over sine 55.32. That gives me 24.20. So 24.20. And down here, do the same thing. 22.8 over sine 55.32 equal side C over sine 8.59. So side C down in case 2 has to be 22.8 sine 8.59 over sine 55.32. Type that in real quick. .14 centimeters. Or no, we're talking about feet in this case. So in this particular case, we end up with two triangles. We check for geometric accuracy. Smallest angle, smallest side, checks out. Largest angle, largest side, checks out. Middle angle, intermediate, checks out. Case 2, largest angle, largest side, checks out. Smallest angle, smallest side, checks out. And intermediate checks out. In this case, both of these triangles are valid. This would be solving with law of sines, where two triangles are actually valid answers. Okay? Finally, number 6. You should pause the video and try number 6, see if you can get through it. Okay, you must be back to check your answer. So, looking at number 6, we'll draw a triangle, as always. Angle A, angle B, angle C. I know that angle A is 43.5 degrees. Across from it is 10.7. And across from B is 7.2. Side angle. So that means I'm going to be looking at ambiguous. Check for ambiguity. Alright, so solve for B. So I'm going to do it up here. I know that I have 10.7 over sine 43.5 is equal to 7.2 sine of B. I'm going to go ahead and cut to the chase here. Okay, we have that the measure of angle B is multiply, and divide. It's going to be the sine inverse of 7.2 sine 43.5. And then on the bottom will be 10.7. And we'll type that in real quick. 7.2. You get 27.59. Alright, 27.59. So that could be case 1. I'm going to do 180, subtract 27.59, and I get 1, so case 2 of 152.41. Well, this does not work. 152.41 plus 43.9, or 43.5 would be 195.91. The other thing we need to look at is that across from angle A being 43.5 degrees is 10.7. That would mean, and then we look at across from B is 7.2, since the side across from B is smaller, or a lower measure, than the side across from A, B has to be an angle that is smaller than angle A. That means case 2 would never work. It has to be smaller. Therefore, B can only be 27.59. Well, let's go ahead and solve for C. Angle C has to be 108.91. And solving for it, we've got 10.7 over sine 43.5 equals side C that we don't know, sine of 108.91. So C has to be 10.7 sine of 108.91 divided by sine of 43.5. That gives me 14.71. Okay, checking it. Largest angle, largest side, checks out. Smallest angle, smallest side, checks out. Medium angle and intermediate side, checks out. So there's only one answer for this solving of triangles. Okay, with that, we are going to stop. Next video is going to be law of cosines.